Right, and you're live. That works. And then oh, you need to. No, you shouldn't need to sign in for that. That's when you sign in to get it. There you go. And then we'll share your screen.
I just did this.
Yeah, I don't know why I didn't keep you signed in.
Great.
Don't you love two-factor auth? All of our services are worth using.
Yeah, no, we have to.
Oh, signed you in. No, you're good. Not sure why you even wanted to auth that. Usually Hangouts you can join.
Well, usually Google's pretty good about federating, so.
Yeah. We get it. She wants to hang out.
Oh. They sent me a second. We've got job security. This technology works so great. We're not going to be unemployed anytime soon.
No. AI's going to come online and be like, you guys are fucking it up, man.
There you go. I hope it takes yes. That's interesting. WorkSounds thinks I'm in Las Vegas.
Doing something. The Google logo came up.
This is just gremlins, man, because I understand why this might be slow. This phone shouldn't be slow.
It's doing something. It's just doing really slowly.
Okay, well, it just got through the second factor again. Well, it connected to my phone.
Should be prompting us to join the thing.
Might be part of the problem.
Say allow. Okay, got it. You got to check the box.
Oh, that much.
Yeah. Cool. All right, so join. And then, yeah.
Technology. And now I'm echoing. Did you try meeting me?
You are muted. Yeah, we're muted on that. We don't care. No language is perfect, or we don't be programming less.
But the reality is, there's a bunch of languages out there because they all suit a particular purpose. I think JavaScript has proven itself to be a pretty good general purpose language, as evidenced by its ubiquity these days, not just in the browser anymore, but pretty much everywhere. Anyway, we meet once a month to talk about JavaScript. And we're always looking for people to speak about JavaScript. So if you guys have an idea you'd like to come up here and talk about, anything is fair game as long as it involves JavaScript. So let us know. Some housekeeping stuff. First, let me thank our sponsors. WorkZones is hosting us tonight. They're kind of our regular home. So let's thank them for making this amazing space available to us. WorkZones is a co-working space and meeting kind of space. If you're interested in checking out what they do here, we can get you a guest pass to try out the product and give them their support. We are grateful for them as a sponsor. They've been hosting us now for the better part of 2 years. The pizza tonight was from another sponsor of ours, Agilicis, who's my employer, at least now. Agilicis used to host us quite a bit as well, but we've sort of outgrown the space that we have in our office here in Santa Barbara. But they've been gracious enough to be providing food for us also for about the last year or so. So we're grateful for that. We also have PayJunction as a sponsor. We have our last 2 events there, and they do a great job hosting us. They usually also provide some food and sometimes beer and things like that, so we're grateful to them as well. And lastly, we have a partner relationship with O'Reilly Media. Through that, we get discounts on books and videos and conference passes. And if we use the conference discount 3 times, I get a free conference pass. No, seriously. No, I'll give one of you guys the pass, but it's because my company will pay for conferences. But it's kind of a cool little benefit. If you guys want to find out more about that, let me know. There's also a posting in on the discussion board on meetup.com. Check that out. We have a Slack channel. I'm looking for an intrepid soul to go and program up an auto registration interface for us because I just don't have time to do it. But meanwhile, if you want to join the Slack channel, let one of us know and we'll send an invite to you. It's kind of quiet. We want to get more people on it so we can get some conversations happening and kind of get the community enabled on Slack. What else do I have for housekeeping? Next month, we have a talk on object-oriented design patterns in TypeScript by Lee Nathan. That's going to be back here at WorkZones. Don't have anything for September or October yet. Sorry, that's September. I have nothing for October. I might have a guy coming in from out of town in November. So if anyone has something they want to talk about in October, that's awesome. Otherwise, I'll get up here and recycle one of my talks. And you guys get sick and tired of hearing me talk. So I think that's about it for the. Oh, one more thing. We're looking for people to join the team. If you want to get involved in this community, ultimately communities work by people getting involved. It takes a lot of work to put these things together. It may not look like it for me just to stand up here and talk to you guys for 10 minutes before our speaker, but it takes a lot of work, getting speakers, getting sponsors, getting locations, securing dates, and all that kind of stuff like that. And we're really looking for somebody to help us with the speaker portion of it. So if you're outgoing, you like JavaScript, you want to curate speakers for us, suggest topics, things like that, please let me know, or let Garvin know, or let Joe know. We really want someone to, this is your group, guys, and the way we make this work is by getting involved, right? Don't be apathetic, get involved, and get up here and do this. I think that's about all I've got from a housekeeping perspective, so without further ado, I'm going to turn it over to Joe. Okay.
The green is on. I think I'm live. Thanks everyone for coming out. This is a pretty good sized audience. I'm going to be talking about Bitcoin and a little bit about other altcoins, and I'm going to get into and frame how you can use JavaScript to interact with it. I'm not going to tell you how easy that is, because it's not. But I will give you enough such that you can leave here and start playing around with it if you want. I had a really rough time with it, but I can paint the roadmap and you can go explore on your own. So Bitcoin and JavaScript, that's me. This is also me. So 25 years I've been a professional developer, entrepreneur, consultant. And in the last couple of years, while most of my day job has been using JavaScript on embedded systems, mostly interfaces for cameras, I've gotten involved in online identity, digital identity. And that ended up pulling me into something called self-sovereign identity, which is based on using the blockchain to anchor a user-owned, user-controlled notion of identity. So these are some of the things that I've been doing. And when I heard the pitch to go talk, or to come talk, I said, well, one of the ways you can master a topic is by teaching others about it. And I encourage you guys to do this. If there's some topic you've been nibbling at, go dive into it, commit to a talk, and you will become a whole 1 or 2 levels better than you are right now on that topic. So that's what I did. So I'm going to introduce sort of this conceptual stuff that I've been working in, how Bitcoin works. For some of you, that'll be old hats. For some of you, hopefully some light bulbs will go off. And then I'll get into my experience trying to write some JavaScript that actually interacted with blockchain in the last week. Okay, so I think I already talked about this a little bit. So Bitcoin and blockchain, I'm going to talk about not just the FinTech, but how people are using blockchain beyond FinTech for identity or governance or what have you. And then I'll get into the JavaScript. Okay, so what is it? It's cryptocurrency. It's doing really well. It's actually at 3,300, maybe 3,400, and we've got a current price.
It's 33 something this morning. Yeah.
There's more.
It's at 34.50 on some exchanges. But
There you go.
33.80.
Right. So approximately $53 billion of market cap, and that's without an IPO. So a guy named Satoshi Nakamoto wrote this thing in 2009, got it started, and an insane amount of value has been created, and that's just in Bitcoin. It's not a piece of software, I'll mention that next, but it is a specific blockchain. So when we talk about Bitcoin, we mean a specific instance of a continuous chain of transactions. And I'll give some representation to that, so hopefully that makes sense. And it is the leading permissionless public ledger. And I'll explain what that means. What is not is not tangible. Someone's trying to sell you a physical Bitcoin, they're ripping you off. It is not anonymous. There are people in jail because they thought it was anonymous. The guy behind Silk Road is in jail because he thought it was anonymous. They recently found guys who busted open Mt. Gox. The fact is, they're pseudo-anonymous. All of your transactions are visible to everyone. It's a public ledger. So all they have to do is watch to see who spends that money. Of course, if you never spend it, fine. But if you steal $30 million, $40 million, $50 million, they're going to invest. And they're going to bet, oh, look, that ended up at Starbucks. Let's go talk to Starbucks. And Starbucks will start to talk about where that happened, and maybe they'll be able to find you. So it's not anonymous. It's not software.
What kind of coffee do you have to order to spend $30 million?
You just need to spend a quarter, man. You just need to tip them in Bitcoin.
Right.
Because it's all on the ledger, so they can track you down. So Bitcoin is also not software. It's a set of APIs, and it's a set of emergent APIs that evolve through something called Bitcoin Improvement Proposals. So there is no central standards file. It's not like HTML that's controlled by the W3C, or TCP and IP, which are controlled by IETF. Literally, the guys running the network and put forward proposals into it, then the protocols change. And this, I'll explain some examples. Some of this has just happened recently in some interesting ways. I won't get too much into that, but I will give some examples. It's also not purely speculative. So, you didn't like the volatility. A lot of people love that volatility. It's definitely created millionaires, but there's real value being created. And so I'm going to unpack that, and hopefully you'll see what the bigger picture is the actual functional value of this public ledger system. Okay, so I mentioned blockchain a couple of times. This is the technology behind Bitcoin, just like HTML and HTTP is the technology behind Google in terms of a website. Blockchain is the technology behind Bitcoin. And it is a specific way to manage a distributed ledger. There are other ways to do it, but a blockchain is a particular way. I'm going to outline how that works. It can be permissioned or permissionless. So Bitcoin and Ethereum are permissionless, means anyone can access it. Anyone can contribute, anyone can participate in managing the consensus of what the ledger is. Permission systems, on the other hand, there's a closed circle of people who manage it. And for some enterprises like the UN High Council on Refugees or banks, they prefer a small closed system. So I'll talk about that a little bit. There are also other blockchains. We talked about these other altcoins. For those of you who may not have heard that, right? Ethereum is another one. Dogecoin. There are hundreds. Some of them have different rules, have different capabilities. Some of them have exactly the same rules, like Ethereum and Ethereum Classic, which I'll explain. Okay, so the blockchain is a ledger. So anyone here taking accounting? A couple of you? Okay, so the core of accounting are debits and credits. You maintain a chart of accounts, you keep all your transactions, and for every transaction you post, it all has to balance. You have to debit, and then you have to credit, and it's got to add up to 0. So every transaction on the blockchain sort of looks like this. I left out some metadata, but this is actual data from a transaction where I got some free coins on the test network. These are the identifiers. Here's the guy who gave me 1.1 testnet bitcoins, and I paid a fee, or he paid a fee. There's a transaction ID and there's a script sig, and the script sig is basically a signature on this. It's a little bit more complicated than that, but for what we're talking about today, frankly, I really don't know all the different ways it works. But basically, this signs this transaction, so you know that it has integrity. If someone changes this number and they don't have the proper sig related to the proper incoming ID, then you can tell. You can verify it mathematically, cryptographically, and know that it's an invalid transaction. So this is sometimes referred to as triple entry bookkeeping. And if you Google that, you'll get some nice posts about folks saying this is the thing everyone misses about blockchain, and that this is just as important as double entry accounting was when they invented it 500 years ago, whenever they did it. And this is why blockchain is going to reinvent how almost all of our transactional capabilities happen. Okay, so it's a blockchain. So all those transactions get organized into a block. I'm going to end up putting little dots down here. But each block can have up to a megabyte of transactions. A little people are frustrated by that. They want to increase it. That's part of what's going on right now with some of the proposals. The block itself is signed. All of the accounts in here must balance. And if someone tried to spend twice from the same account, then it's an invalid block. So the person who puts together this block has to make sure it all adds up, and that you don't have two accounts spending the same amount of money, which is actually happening here because I just copied and pasted. Yeah. That's happening all the time. So this is a completely invalid block. But this is one of the stages at which we fight what's called the double spend problem. And I don't have a slide or anything on that. So the double spend problem is if I have a physical dollar, a physical species of currency, then there are techniques for me not to be able to photocopy it the account easily. If that's just digital, if it's a photograph of a dollar bill, I can copy it and I can email it to 100 people, right? That would be 100 spend. The whole point of how blockchain makes a difference is they figure out how to stop that double spend. And one of the ways it starts to stop is that this block can't have two spends from the same account. Okay, so it's a chain. I feel like this is a little pedantic, but it's really simple. So those blocks point to the block before the chain, all the way back in a single continuous thread, all the way up to the Genesis block that started all off in 2009. So I actually looked online and watched 20 or 30 explainer videos because I couldn't believe that there wasn't something I could just show you and sit back and say, okay, watch this for 5 minutes. But they all annoy me for various different reasons. And one of them was they keep showing this with multiple different connections. Because I think they're trying to show that the chain itself can be distributed amongst all the computers who are participating in the consensus mechanism. But the reality is it's one continuous chain. Altogether, that list of transactions, that's the ledger. Does anyone have a copy?
I always thought of it like a Git tree, not like a line, a chain. Maybe I was reading the same things you were reading and misunderstood it.
Yeah, so it's definitely not a tree. There are representations of a tree. A given transaction can split money, right? You can have money from one account, go to multiple accounts. In fact, that's pretty difficult because you have to spend all the money. Like, let's say you have 100 Bitcoins, that's all you have. If you create a transaction that gives someone $10, then the transaction says, oh, we have 100 in, we're giving one person 10 and another person 90. So that kind of works. But the blocks, there's always one preceding one. Because the whole point is that it's ordered. At the end of the day, after consensus is achieved, it is a guarantee to be a well-ordered set that the majority of miners agree on. So and the importance of that is because if I have 100 Bitcoins, I give you 100, and I give you 100, I give you 100, the guy who claims it first gets it. And so the ordering is how we help resolve the double spend problem. Okay, so that's what it is. Now I want to talk about how it works. Fundamentally, there are two roles, and it's really frustrating. There is not a standard term of art for the spender. Most Bitcoin conversations, blockchain conversations, talk about the miners. But the reality is most of you are never going to be miners because you don't need to be to use the blockchain to post transactions. So you can make money on speculation, you can spend money back and forth without ever having to be a miner. Miners are the ones who maintain the ledger, and as a result of their mining and generating the consensus, they get Bitcoins as a result. That's how you make money directly off of the blockchain. Spenders simply post transactions. They pay fees for those transactions, and they don't need a copy of the ledger. So two fundamentally different roles. But anyone, literally anyone on the planet, who can run a computational device that's connected to the internet can do either of them. However, everyone needs a wallet. And when I say wallet, I mean this file. This file, I don't mean a piece of software. In most systems, it's called wallet.dat. That contains all your private keys related to all your transactions. So if you lose that, you cannot spend your Bitcoins. If you have a fire, you lose it, you get mugged, and it goes on your USB, it's gone. There is no way to restore it. There's no centralized authority. You can reset the password and get it back. There are mechanisms where you can put your wallet or part of your wallet in an escrow service physically. You can go down to the bank, put it in a safe deposit box. There are more sophisticated services, etc. And if you had $10 million in Bitcoin, you would probably be doing that. Or you should be, because it would be worth it. So that's the wallet. Okay, part of the magic of how blockchain works is something called proof of work. And that means what the miners do is they do some hard work. I'm going to explain that hard work. So hopefully you understand it mathematically. So every block, they calculate a hash. Hash just runs through the block and comes up with a number. It's, does anyone know the hash? Whatever 256, SHA-256, the hash. So the thing about the hash is you can only go one way, and it's very easy to calculate. And if you change one bit, the hash changes wildly. So it's got high variance based on small changes. So what Bitcoin miners do is they're trying to find this little bit of data that they add to the block such that the hash has a certain number of zeros in the front. 5 zeros, 10 zeros. It's how the network tunes how long it should take for a block to resolve. So Because of math involved, it's just a brute force. We don't have any analytical way to do it faster. So the miners are literally just trying another number, until they can get the magic knots that gives the hash with the zeros. And as soon as they get that, they go bingo, and they publish to the network this block. The block, right, points to the previous block. So now everyone knows the number of this block and the length of the resulting chain. And that miner now has a chance to earn Bitcoins. And the Bitcoins they earn are from transaction fees. And right now the block pays out 2.5 coins to the to that one. So the block itself will just generate 12.5 coins. That's going down, I forget the year, 2020, 25, whatever, it will be 0. The only money they will make is from transactions. It started at 50 coins. It's been halving every so many blocks. So why isn't that a sure thing? Because two miners might simultaneously yell bingo. And by simultaneously, I'm talking about the speed of light and the speed of the network. So if I'm in China or I'm in India and I'm in South America and I'm in North America, we could all yell bingo, but the time it takes, there will be plenty of people who can't tell who yelled first. So that leads to a fork and a race to achieve majority across all the miners in terms of recognition. And the way that recognition is actually really subtle. It's really kind of brilliant. The longer chain wins. So every miner is incentivized to work with the longest chain they can find. So if I'm working on a chain with, whatever, I'm just going to say 5 because it's easier to get on my map. I've got a chain that's 5 blocks long, and someone shows me a valid chain with 6, boom, I'm going to move to 6 because I can't compete with 6. If I get my nons and I'm the 6th block, well, I'm already number 2. I'm not going to win that. So as soon as I hear about another chain that's longer, I'm going to start working on that chain. So very quickly, the whole network grabs and gravitates to the longest chain they can find, and the majority will resolve.
I mean, so that's not, you got a whole blockchain history, but you don't need to have a whole blockchain history to mine, do you? That's like, how big is that file?
So you basically need just the last hash and the hash of the numerical group of all the transactions in this one.
Yeah, okay.
That's what you need.
Yeah, so that makes sense.
Yeah, so you don't need the whole blockchain. You're not hashing it. You're just hashing this block plus the signature from the last block.
Okay. But so then what you're talking about, though, and have the longest chain. So how that play into what you were just saying there?
So the only way you know if a given block is valid is if it devolves back to the root. So typically, if you're validating the blockchain, you've probably been doing it and you have a cache, and it's not that big a deal.
But you have to go all the way back to the root, or you can't just go back to yesterday?
Well, if you know yesterday's block and you trust it because it's in your computer and nobody's messed with your computer, then you can use that. But if you're new to the network, then I can give you a block and say that it's connected to Nakamoto's chain, but it isn't. And the only way you can know is if you actually dereference every pointer all the way back. So yeah, that's why miners typically work with what's called a full node, and they will download all the nodes, all the blocks, and do the math. Now, calculating the hash is fast. You only have to calculate, you only have to find the nonce for the latest block.
I guess when you're talking about the longest here, you're saying from, let's say, like an hour ago, I've got 5 transactions that have happened, and I say winner, and you've got 7 transactions that have happened since then. You say winner, that you win because you've got the longest chain in that complex. Is that what I mean?
Correct. Right. And normally it's for me to have 7 from some metric and you to have 5, we've been separated for a while. And someone way over there, by the time both of our bingos get to them, they can say, oh, well, one guy has 5, one guy has 7. And they both resolve the root as I understand it. So I'm going to take the guy 7. Because I want to be 8, not 6, because 6 is already a loser.
Is it possible for that to happen like multiple times so that you could actually have a fourth of the ledger that is more than one transaction long?
Yeah.
And
So
doesn't that open up a huge, like a ton of problems? Like what if there are like dependent transactions in that fourth that eventually go away?
Yeah, so a given transaction is generally not considered valid until it's confirmed 6 or 7 times. Depending on how risk averse you are, you can wait longer. So waiting for an hour is 6 blocks, typically. And that should give you about 6 sigma confidence that that's a stable transaction. But there could be some freak events, and boom, all 6 of those go away. And it just means that the only real risk is if there's a double spend in there, right? So someone gave you money and you gave someone on that other system money. For most transactions, that's not the problem. You just want it to be stable so you can drink your coffee. It is kind of lame if you're waiting an hour before Starbucks says, yeah, your payment's good, here's your coffee. And a lot of people have alternate coins that are trying to address that, like in sidechains. Ethereum is actually 12 seconds a block. But interestingly, 6 sigma is still about an hour away. Because they have far more changes, far more reverts, far more forks.
If you we have the 2 split, 2 working letters, actually 2 people, we want smaller again, literally all the way up to our subject, put back in the pool, and they're being raised to the
Correct. So if we're both working on the chain with different transactions that are blocked, and you win, then the transactions in my block that were not in your block are still what's in, it's called the mempool. And you can get transactions stuck in the mempool for other reasons. And if the transaction is there for more than 72 hours, it'll evaporate. And the reason it might get stuck there is because there wasn't a high enough transaction fee associated with it. So if you're too cheap when you're trying to get a transaction done, typically it takes a little bit longer. But it could, if it takes more than 72 hours, then you're hosed. And there are actually 2 protocols that let you adjust that transaction. Either the payer can do an RDF, which adjusts it retroactive, or it takes what's in the mempool and changes it, or someone who wants to rely on that transaction can increase the fee. I forget the acronym for that. That's right. CPP, I think. Or CPFP. Okay. Yeah. Okay. So with this mechanism, this is how we get rid of the double spend. So every block, we know there's no double spend. And if you spend in 2 different miners, then the consensus protocol will resolve which double spend is valid. Which spend of the duplicate is valid. And it can't, we just talked about this, it can't take several blocks to actually resolve the forks. So the fundamental value here, the non-speculative value, is that Bitcoin is compensating miners to use a consensus mechanism to audit this account. So it's for the cost of these transactions. It's like having, Accenture or PricewaterhouseCoopers or someone audit this global ledger. But no single entity is in control, right? Anyone can post transactions, anyone can audit it, anyone can look at it and see if it makes sense, see if it's valid. And anyone can mine and participate in the consensus mechanism. So it really isn't the coin that's valuable, just like the dollar in my pocket, that piece of paper isn't important. With Bitcoin, it's the audit trail. We've got this continuous ledger, and we can know, oh, that really was there. Because all of these people have spent all this computational power, and they've all agreed over blocks and blocks and blocks for days and days and months and years. Without a centralized authority. So you can't have the Federal Reserve lie about it. You can't have a dictatorial government lie about it. We're gonna run into that shortly.
Or you explain how the calculation that they do actually influence the blockchain? You give an example, give a total they got come up with this 90 number with some number of preceding zeros on it. How is that helping in the blockchain, validate the blockchain?
Verifying transactions.
Is that magic number somehow related to a transaction?
The magic number will be unique for any given block, and it's hard to find.
So it's basically, that's the part of it, that's validating that block, is that you're told, okay, here's this block that is not valid, here's the magic number, here's the hash of it, please tell me what number resulted in that hash.
That's right. And so, right, the fundamental transaction is the miner's getting paid for doing the audit. So the way you know that it's a valid audit is because the nonce and everything else adds up. The guy who gets the nonce first, he gets the money. And that's sort of arbitrary.
He can't choose to pay to anyone else. He gets money because it's the obvious thing to do, but actually the first transaction is one that pays that coin, like anything that has not been claimed, that's the transaction pays plus the block reward. And you pay that to an address. It's like a regular transaction, like any other transaction. And he chooses to pay to himself. So he can pay to anyone he wants. He decides who collects that reward.
Yep.
So from like just economic perspective, people talk a lot about like intrinsic value. And so is the intrinsic value of Bitcoin just the fact that it exists on the ledger?
Well, the intrinsic value is that 50% plus 1 of the miners agree that that is the state of the ledger. And the reason we have all these computational resources wasting their time, if you want to be pejorative about it, because it's literally billions of dollars a year on electricity alone to keep this thing running, is because they get Bitcoin side.
Yeah, 50.1%, but it's not ownership. Values and fiat currency, so it has more value than a dollar. That's just someone's willing to accept it for their service.
Right now, I mean, the value of the system is we're paying the Bitcoiners to do the auditing. And because they all agree, then every 10 minutes we give someone else a lucky penny. And everyone's hoping for a lucky penny.
Right. And the reason the lucky pennies are valuable in the first place is because they've been verified by this massive computation.
That's because you're willing to spend $3,000 for this.
Would the intrinsic value be from the work that the miners are doing plus the lunchroom cost? There's a hard cost behind mining, or reason this value to Bitcoin?
You might be right, and I think it gets into semantics in terms of economics. But I would say that's the intrinsic cost.
Yeah.
The value to someone relying on the system is that they can validate, that they can themselves go through the ledger and not only know that it mathematically adds up, but a significant portion of people have agreed that it adds up.
I mean, a financial system has value, that's what they say. So if you want to get philosophical, so what's the value in Bitcoin ledger? Is that it would enable much financial transactions that has value to all of us. So
that's right. And I think some economic theories of value would start with the intrinsic cost. So I didn't want to say that was wrong, but to me, I want to talk about why do I care?
So what I think is that, I read this, is that Bitcoin has like the same properties we give to money. First, it's scarce. Second, it's fungible. And I forgot the third property. but the point is, you can use it as money, and it's very effective, it's fast, and it's reliable due to all the adjacent infrastructure that's there. So that's what's linked to value. It's first of all, the scarcity, and second, any two Bitcoins are the same. You cannot tell them apart.
That's right.
So they're fungible, and that's reversible. You can have like 1 million a Bitcoin. So you can buy between 100 million parts, and you can use that as any other Bitcoin. So those three properties that are shared between money and Bitcoin is what makes it usable as money. And keeps it somehow because you want to keep track of how much they own. So there's a service.
So you said in 2025, the reward for mining will go to zero? What will be the incentive for auditing?
Well, what was the term you used? The 12.5 cents.
The reward.
Yeah. The reward. So that goes to zero.
Yeah.
Every transaction you put on the blockchain, you're going to pay a transaction fee. And right now, I think it averages about $1. Right. So the miner will get that $1 for all the transactions. I don't know how many transactions are typically in a block to make money. So it could be, I don't know, if it's $1 each, that feels like a lot of money. Could be.
From a practical standpoint, right now, wouldn't you say that the intrinsic value of the Bitcoin, at least as it stands right now, it comes from the Bitcoin to dollar transaction amount?
Well, that's the transactional value of it.
Right, well, isn't that what's giving Bitcoin its value right now, wouldn't you say? Or are there enough transactions happening within the Bitcoin network that that's where its value is actually?
Well, one of the reasons I define the intrinsic value the way I do is because when we move away from FinTech, it's really just that there's an audited ledger. And now you can do other stuff with it. Right? It's not like gold where gold can be turned into jewelry or can be used in electronics, right? That has an intrinsic value because of the material itself.
Yeah.
Yes, we generate these nonces. They're magic. But the only magic they do is they make zeros when you run the hash. It's not that exciting a magic trick.
I guess I mean, from a practical standpoint, do you feel like people are owning Bitcoin because they're able to make transactions, or are they owning Bitcoin because they're able to exchange it for the US dollar at a certain rate?
Yes. So I think a significant portion of the capital investment is speculative right now. But there are a lot of people using it for transactional value, and those transactions matter. And it's the ability to have this transaction that's pseudonymous and that doesn't go through centralized authority. So somehow we bootstrap that this feels and acts like a currency. And now that it does, and it doesn't have a central authority, people are selling guns and drugs and all sorts of stuff. Some of them are going to jail because they don't understand that it's not anonymous. But they're using it to buy things because the nature of the financial system is perceived to be favorable to them instead of using a credit card or bringing a suitcase full of cash.
Yeah, a suitcase full of cash, its intrinsic value is you light it on fire and could be one, right? That's basically it. Beyond that, it's purely, and I can trade for cool stuff, that I can trade for food or chocolate or something like that. So this is even, you can't even light this on fire.
Yeah, so the transactional value of any currency is what people give you when you give it to them, right? What can you trade it for? And we have markets that we watch, and that's why we know it's $3,400 today, because there are markets where people will buy one Bitcoin or a fraction of Bitcoin at a rate that equals that amount.
Yeah, the system has a lot of value. It's this automated system and that.
That's right.
So I got to figure out what I do here, and you can put that all down to business context.
That's right. Yep, and so we're going to unpack that next. So I already mentioned these two a little bit. Permission systems are very exciting for a lot of people. I'm going to talk about hyperledger just a little bit. Especially for people who want a closed system and then they feel they can trust whoever their peers are. Banks are a good example. There are also several alternatives to the proof of work. And I'm not going to get into them. If you go and look for alternatives to proof of work on Google, you'll get a bunch of examples. It's proof of stake, it's proof of capacity. I don't even understand all of them. But these are alternatives to that nonce thing. Why do this crazy hard math problem when you can maybe have other smarter ways. All of them have problems, but people are exploring them. Okay, so Ethereum, the most interesting, well, there are two very interesting things about Ethereum, although the ICOs, which I have a whole other slide about, is an instance of these smart contracts. So Ethereum, every time they calculate the nonce, well, not when they're mining for the nonce, but the block, they will execute code that's attached to every transaction. So there's a Turing-complete language called Solidity, and when I go through that block and I balance the block, I also run the code that each of those transactions have specified. And depending on the operations that they're engaged in, they may pay different amounts. Certain operations are more expensive in Ether, which is the underlying currency in Ethereum. There's a generation of computers, I'm sure they're still out there, that were built around tell me 3 times. These fault-tolerant computers, standard computer was one of them. We used it to build out the ATM network, we used it to build out spaceships. The idea was you would have 3 isolated systems all running the same code with the same data, and if all 3 of them agreed, then the system would proceed with that conclusion. If one of them didn't agree, then they would cut that one out and then go with the other 2. So Ethereum is this tell me n times. Only if all the miners, and by all I mean 50% plus 1, agree on the outcome of the computation, do you rely on that computation. So in the space shuttle and systems like that, literally a gamma ray could come in, flip a bit, and your spaceship crashed. So they would have these redundant tell me 3 times. So Ethereum is doing that with Solidity. And people are doing lots of really interesting stuff with that. It's a computation platform, so people are building apps on it. They also have faster blocks. I mentioned this about 12 seconds. But people know better than I said, if you want to get to that 6 sigma, it's still about an hour. Because you're forking more. Because every 12 seconds, basically they tune the nonce so that it's happening faster, which means you get more conflicts, you get more forks. You get longer chains that get reverted. Ethereum also allows these custom tokens called ICOs. And these are basically smart contracts that let them sell these tokens that are tied to a specific architecture, a specific subset of rules that aren't necessarily what Ethereum is. They're smart contracts. They are anchored to Ethereum, but the reality is how they're being used today is like an IPO. And I'm going to give some more examples. I'm going to talk about the DAO. I'm going to talk about Filecoin. I don't know if I can show you the video for Filecoin, but in the last 12 months, so I saw something in June that said it was 330 for the year. And then I saw something at the end of June that said in the last 19 days we've got another 700 or something. I mean, it's ridiculous. So, an insane amount of money is being raised by these people saying, on Ethereum, here's a smart contract. So now I'm going to sell these tokens. They're going to be tokens. Maybe Joe tokens. It's tokens. And everyone who buys you to give you a tenth of a Bitcoin, I'll give you 1 token. And because of those tokens, you're going to get a royalty stream off of all the jokes I tell. That would be a valid ICO. Probably wouldn't make much money because I'm not that funny.
That's your point.
And so VCs are actually getting into this game in a very interesting way. Because what they can do is they can provide some marketing and some packaging and some storytelling assistance to startups that have an interesting idea, help them launch an ICO, and they can immediately be liquid. They don't have to wait a year or 2 years or 3 years. If you're in a unicorn startup, when do you get to cash out? Well, if you're in a unicorn ICO, you can cash out right away. That's changing a little bit because people are looking to put in these smart contracts, notions about vesting, but still the liquidity in the tokens is immediate because you can spend them in the architecture unless something that's smart contract limits it.
So this is kind of like a spin-off of Bitcoin, right? Like it's Bitcoin came first, and then this came, and it's similar, but with its differences.
That's right.
So
They're both blockchains.
yeah. Did Satoshi Nakamoto, or did he just kind of out of the blue come up with this idea of blockchain and Bitcoin, or were there things before it that kind of led to it?
I don't know any of the precursors. He wrote a paper in 2008, and then in January 2009, released his document. And nobody knows who this guy is. It's estimated he owns a million Bitcoins. And the way the market's going, he may be the first trillionaire on the planet. He is a billionaire now. Yeah.
It's like Kaiser Soze.
It is like Kaiser Soze.
Yeah.
Exactly right. Sorry, we got you. Why don't you go ahead?
I was just going to say, in regards to this question, there was some elements that led to Satoshi thinking about this stuff. In the 90s, when the internet was coming into play, there was a lot of talks of digital cash, and they kind of attempted it, but it never really worked. There was something I think was called like digital gold or something like that. But
Zigo.
what was that?
Zigo.
Zigo. So there were a couple of things that led to the creation, but the proof of work was a new concept. The actual blockchain itself was a new concept. So he used some previous ideas and kind of merged them together and created some new ones at the same time. But yeah, he's right. In terms of the blockchain, the proof of work, that was kind of all new stuff.
Or was this the first public ledger proposal?
That, I think so.
I think it's the first ledger in all.
Yeah.
I mean, the private ledger is really saying, oh, hey, we could use, it's kind of like intranets, right? And we don't use that term anymore, but yeah, you can build a website and just let people inside your company use it. But it's still just a web page. And that's really what private blockchains are about, permission blockchains. Like, oh, we can reuse this. I'm sorry, were you?
I'm surprised you didn't bring up Hal Finney when talking about like the creator of Bitcoin.
Tell them about Hal Finney.
Yeah, that's the first Bitcoin transaction. So like, if he's not Satoshi, at least you know some intimately. I mean, coming from Genesis Block, he's the first person to post publicly about it. It's like a reference other than like Nick Zalo, who did Bitgold and all that. So yeah, I mean, either that or like Mark Wilcox for sure. I mean, those three guys kind of narrow it down. I couldn't even grasp the concept at the time. Like, really narrow, like amount of people who could and like put that together. But unfortunately, he's passed. So yeah.
Hopefully, he didn't take his private keys with him.
I think his wife is. She's still here in Santa Barbara.
Yeah, he's local.
Yeah.
He's A-time.
He's what?
He left it in his case. He's got like thousands of points.
Yeah.
Did you have something?
Oh yeah, so in your example, the joke one, so you said like all pay royalties from that, right? But what, is there something about smart contracts that guarantee that that royalty stream will be paid out, or is that just?
Yeah, and I don't really understand how it works, but there's something called an outside oracle that can be an input to the contract. So it could, for example, monitor
The interest rates.
right, it could monitor interest rates, it could monitor the, Dick Clark's top 100 song, whatever. A lot of that information is available, so you can use that as an oracle to drive, and the transaction will just happen. And the tokens will show up in people's accounts, if it's constructed that way. You can also set up a contract that, oh, Joe will pay when Joe feels good, and that's how we resolve it. And that would get fewer buy-in because it's less buy-in.
So there is the everyday sensitivity to whatever the outside world is, right? Maybe you're calling the API and pull the library number, but if that API gets compromised, it's not fully self-contained.
There's been a lot of exploits in the smart contracts, actually. I think that's what you're touching upon. And if you can bring up DAO.
Yeah, where do you get the DAO is one of the biggest exploits. You know, if you have sensors to get data from the outside world, then those sensors can be compromised. It's just, That's just systems, right? If you can't trust your eyes, then you don't know what you're seeing. Okay, so we're going to get into the DAO here, I think, next. So this is, without a doubt, the most famous ICO, the Distributed Autonomous Organization. It was essentially a venture capitalist fund where the people who owned the tokens would evaluate proposals. Anyone could propose something, and if the people who owned the tokens, I think it's 20% was the threshold, if 20% of them voted, then the money would be distributed, and that project would get funded. It was an exercise in radical self-governance, and I lost $100 because I tried to get into it, and I couldn't get my money into Ether, and then I sent it to a bank that said they could send it over, and the bank said, no, we're not going to send it. Anyway, there was a lot of people very excited because it was this completely radical new way to organize a company. But what happened was there was a bug in the underlying smart contract. It wasn't a bug in Ethereum, it was a bug, it was actually in one of the libraries that was baked into the DAO smart contract. Guy pulled out $30 million exploiting this bug. The guy who found the bug noticed the guy was taking the money, and he reverse hacked. They used the hack to get out the rest of the money and put it into a secure account with the intention and the fact that they followed through to give it back to the people that they actually took it from. So it's a little bit of a Robin Hood to keep the guy who was hacking it from running away with all the money in the DAO.
At that time, it was like 30% of the total market cap.
That's right. The DAO was a huge percentage of the whole Ethereum market cap. So it was the flagship. In fact, the price of Ethereum went up 30% on the DAO offering. And it went back down after the DAO, but it sparked a lot of excitement. There was a proposal to do what they call the soft fork, which, we can just undo that. But they realized that created a security problem and it would open them to a denial of service attack. And so they didn't do that. And it turns out that was actually really good because if they could get away with the soft fork, then none of the smart contracts actually ever meant anything. Because you could always have someone execute a soft fork. We still have a problem with the hard fork, but the hard fork is a little bit more painful, so it's less likely to do it. So what's the hard fork? So when the soft fork was shown to be a security problem, they executed a hard fork, which basically all the folks, maybe some majority of the folks behind Ethereum said, we're going to roll back the blockchain to this particular block, and we're going to ignore all the other transactions. We're going to take the money that we got in for the DAO, and we're going to give it back. And they did this not by fiat, they did it in a fairly open and collaborative process. But not everyone bought in. And they literally, right, the blockchain, the Bitcoin blockchain, or the Ethereum blockchain is a single continuous ledger. Well, the old ledger was still there. That's now become Ethereum Classic. And it's trading at a fraction of what Ethereum is, but it's still out there. They're both functioning. It's kind of crazy. It speaks about this emergent governance. You could fork it tomorrow. In fact, I don't have this in here, but someone just forked Bitcoin, took the whole chain, said, okay, everyone who currently has Bitcoin, we're going to give you something called Bcash. I think they changed the rules a little bit. Bcash is traded at $200, $300, something like that right now. Basically, everyone who had a Bitcoin suddenly got $200, $300 for Bcash. It's wacky. You know, it's open source. You can take it and do whatever you want. It's a public ledger. I'm going to copy it. I'm going to call it something else, and I'm going to do something weird with it. And if other people start to use it, then it'll have value for those people who choose to use it. Right? I'm speaking English, but a bunch of us could move out of the room and start speaking French. The same kind of thing.
When did the DAO fork happen?
Good question.
3 years ago? 2 years? What?
In the summer. So we'll have to do something maybe 2 years from now. Sounds right. Google it.
So it seems like, let's say you demonstrate a business deal, get a transaction close, or why does this happen? And also, it's sort of like literally just kind of got screwed. Someone on one of those sides of the transaction got left holding a bag.
Well, remember, someone lost, some collective set of people lost $30 million. And these money. So lots of people are getting screwed. I mean, that was just a big portion of the whole Ethereum market. It's kind of like, all the major stock exchanges have times when they shut down the exchange, or they shut down particular stocks. Right, and they have reverted and said that transaction actually didn't happen. So, to some people, the hard fork says, look, smart contractor, they don't mean anything. It's a philosophical issue. Others are like, look, the humanity of our system needs to trump whatever the technology is. Because in this case, it was a bug. These are complicated contracts, and people don't understand exactly what might be going on. Bugs happen. The fact of life.
Well, in that particular bug was actually written by one of the guys who created Ethereum. It wasn't for the Sun BB contractor.
That's right.
It was a very experienced developer.
That's right. I mean, one of the problems with Ethereum is it's just more complicated than Bitcoin. And more complicated means more likely to have errors. And the more crazy you get, I think the DAO had a pretty crazy sort of interactive model, then the greater the chances that you have an error. And maybe a month ago, something like that, the SEC made a public statement that the DAO tokens were security. And they had no evidence that they were exempt from the requirement to be registered. So until now, the SEC is kind of letting go on its own. And I know people who have done an ICO and they didn't let Americans buy because they wanted to avoid the SEC. It's actually, if you go to the list of things, there's a little tick on as to whether or not Americans can buy. But they also said it, he was just like, well, we're not a real company. You don't get a vote, you don't get a share, whatever. But the SEC is starting to weigh in and say, look, this is like an IPO. And you do need to treat these as securities, and you either need to be exempt or you need to register them. And the DAO, 30 million gets sold, and then they revert the very security that they sold. I mean, frankly, I'm glad that SEC got involved, because it is a security, it was sold as a security, and someone needs to get their head out of there behind it. Who knows what it's going to mean for the rest of the world, but they're finally wading into this. Okay. So Filecoin, I think, is really interesting. One of the reasons it's interesting is their ICO is 2 days away. So if you just get into this and you're curious about what this looks like, so they built IPFS, and what they're doing, that's the IP file system, Internet Protocol File System. And it's basically a way to store a file and it's just in the file. It's more sophisticated than that. But what they're doing is they're building a commercialization of that, a monetization of that. So I can take the hard drive in my home and start selling capacity. I can spin up a server on Amazon and sell capacity. I can also buy capacity through Filecoin and store stuff there. So they are radically commoditizing having bits out there in the file. They are not the only ones. There are 3 others that I found while I was looking this up. Storage had a $30 million IPO, or ICO. A month ago, 2 months ago? Something like that. I think it's a really cool business model. So I don't know if this is going to come up, and we're kind of running late. But check out filecoin.com. It's a cool little video, 5 minutes. You'll get a sense of how sophisticated the packaging and the sales efforts of this are. And this is going to go out in like 2 days. It's going to open. Okay, I want to try to move through some of this quickly. This is the world I live in. This is what got me into this space. So self-sovereign identity means using the blockchain to create and manage identity independent of a centralized authority. So your domain name, you're renting it. You don't actually own it. IP addresses similarly are bequeathed to you through an arcane architecture. SSL certificates come from CAs. So the idea of distributed identifiers, DIDs, is that you record an identifier on the blockchain along with the mechanism that you prove that that's your identifier, which usually is just a public-private key, but there are some more sophisticated things you can do with it. And then I can start using that identifier, and it can start to refer to me. You know, it's just some number. It's not like it's joe.com, toys.com. It's not human readable. But nobody gave it to me. I cryptographically generated it. It's completely independent of central authority. And one of the things about it is because it's on the blockchain, you can also start to update the actual keys to use to prove ownership. And you can revoke an identifier or revoke a key. So there are all sorts of sophisticated things that you can do. So now when I come to John's website and I want to log in and I say, I'm that number, he can go look at the blockchain and say, oh, well, the blockchain, well, that was revoked. So you're lying. You must have stolen that private keys associated with that identifier because it got revoked. There's a nonprofit called Sovereign that's running a blockchain. I forget, it's not on Bitcoin. I forget the platform they're using, but it's for identity. Evernym is a startup, a for-profit that's sort of leading in that push. They recently got folded into Hyperledger, which I'm going to just talk about relatively shortly. And DIDs and self-sovereign identity are being driven through the W3C, which are the guys behind HTML, through a group called Verifiable Claims and the Credentials Community Group, and I'm actively involved in that. And the idea with Verifiable Claims is I have a claim, says I have a driver's license, or I have a doctor's license, or some sort of credential. And it's just an open standard way for me to present those credentials. And DIDs and the blockchain are kind of part of that. Credentials opens that up, but this is a working group standards track. Might be a year before we get something published.
So it seems technically this is true, but is the intention for me to be able to register a public key so that I can actually have like use it as a password, like to log into websites and stuff?
Yes.
So like my identity, not just my identity, but my private key, basically the public portion of my key pair is publicized in a way that I can just say, that person right there is me, and challenge me, and I'll sign something to prove that I am who I'm saying I am, and that's it. You can have a software for logging in instead of having to have a password.
That's right. Yeah, they call it proof of ownership. If you can prove you have a private key for that public key.
Well, I mean, even before blockchain and other coins and whatnot, we were doing that with public key signatures on emails and stuff like that with journalists communicating.
Sure, P2P, what was called the web of trust.
Right. So it's just a more formalized version of
well,
that.
it's now anchored in a reliable consensus-based public ledger.
Mm-hmm.
So one of the reasons P2P didn't work was because you had to have these key parties, and they did have broker services that showed up, but then you had to trust the broker services, so they were point of failure, point of attack. So this, and the way DIDs are working, you can create a DID method, anyone can propose one, that uses any blockchain. So it's not even limited to being on that blockchain. In fact, they're looking for you to be able to, maybe initially you start out with a DID that's on Ethereum, but then you can move it to Bitcoin. They haven't really figured out how they're going to do that, but that's one of the goals. Okay. I know we're running long. The somewhat good news is there wasn't a lot to demo, but I do want to get to what I learned with the JavaScript stuff, so we're getting there. The other half of, and this, a year ago, I went to a UN summit that changed my life. That sounds trite, but it's true. The UN shepherded a Sustainable Development Goals treaty 2 years ago. And the goal number 16.9 is to give everyone on the planet a legal identity by 2030, including birth registration. Turns out there are 1.1 billion people on the planet that don't have a legal identity. somewhere between 11 and 19 million in the US. So these people don't have access to justice. They don't call the cops. They don't sue people. They can't get health care.
They can't own property.
They can't own property. There are all sorts of problems. It's an anchor. In fact, it's a primary technique in human trafficking. Convince someone you got a job for them in another country. As part of that, you have them give their passport to the person who's running the dorm, to put in a safe. Now they're illegally in a country and they don't have their passport. So they've now become completely beholden to the system. So I went to this conference because I've been in this community for a long time. And my brain was melted. I mean, my first website sold hot sauces online in 1994. Solving first world problems. You know, helps Hewlett Packard sell PCs to compete with Dell. These are real world problems, and it was stunning what's going on. So, one of the most interesting projects that I heard about, and I'm hoping to get involved if you can get funding if you want to get me involved. There are 10 tribal camps that are not integrated along the border between Myanmar and Thailand. And it's rough country, and they're like, screw you, Thailand, and screw you, Myanmar/Burma, fascist bastards. And they constantly are crossing the border. It's kind of like the Mexican-US border, and they're illegal immigrant labor. Those camps are all going to go away. And this gentleman, Peter Simpson, who runs iRespond, is going to use self-sovereign identities to bootstrap an identity that these individuals own. And so he's managed to convince both parties in the government and the tribal leaders who are like, screw you, Thailand. I'm not going to let you give me some number. You know, I don't want you to tattoo me or whatever. I don't want to be in your system. He's convinced that this is your identifier. You own it, not the Thai government, not the Myanmar government. But they're going to bootstrap up so they can start providing services, and they can move them out of the gray and black market businesses that they're in right now. So that's super exciting. In that whole conversation about self-sovereign identity, one of the thresholds was, you know, we will know this works when I can get on a plane using my digital identity, my self-sovereign identity. And this guy's the best effort I know. That's sort of getting the government acceptance and recognition of these self-sovereign identities. So there are a bunch of other applications. People working on chain of custody, like this medical device, that it was here, and then it was made here, and then it went to the patient, then it was in that hospital. Food, airplane parts. Delaware just made it legal to use blockchain for corporate governance. So you can have a vote, you can use public key, private key, blockchain recorded. I already mentioned China's food and taxes. Blockstream is doing a thing called sidechains, so it's anchored in blockchain, but then they do something else that lets them do magic. There's a faster transaction where it's micropayments. People using it for education, specifically open badges, and the folks at Pearson and ETS and Thinking Machines. These guys are deep into the W3C verifiable claims work, so that you can take a course and you have this digital badge that proves that you know JavaScript. Banking, I sort of mentioned that. One of the interesting things is, so the subprime mortgage fell apart, in large part because the CDO is based on credit default swaps. And part of the problem was no one looked inside the sausage to see that these things were valuable, right? And there was maybe some corruption around that. But we also didn't know that AIG and Lehman Brothers were totally exposed. So we didn't know that when this value went away, those companies were at risk. So what the banks are trying to do is put it on a public ledger. They're still going to slice and dice. They're going to do the credit default swap, and they're going to try and turn these crappy mortgages into less volatile securities, but they'll know who owns them, so they can properly evaluate the risk at the AIG and the Lehman Brothers. And a number of these IPOs are gambling systems. So yeah, let's use this pseudonymous system to play poker. Real quick note, Hyperledger is an open source project led by IBM. The two pieces of software under that I know are Fabric and Indy. Fabric is for permission private ledgers. Indy is an identity ledger. It's actually from those guys at Sovereign Hyperledger that I mentioned earlier. They Hyperledger basically folded them in, and they're with the Linux Foundation. So they've got really good institutional support in terms of how to maintain that code base. On the other side of the spectrum, Microsoft is playing the game with blockchain as a service running on Azure. It's a horrible name, they acknowledge it's a horrible name. It's based on Ethereum, and they're working with a company called Consensus that's doing some interesting stuff. And you can write Solidity visually. So Solidity is the Ethereum code that runs on the Ethereum virtual machine. And folks like Accenture, deep into it, Microsoft and Accenture using this technology went and did something for the UNHCR on the refugee stuff. So I think these are the two biggest players. AWS has some blockchain offering, but I'm not really familiar with it. I think that's it. No, now the JavaScript. Okay, so the challenges, you're not really going to be able to mine with it. JavaScript is not going to be a mining platform. You could do brute force to try and find that balance. But the reality is, that one was dominated by Chinese players who have custom designed ICs, these ASICs, that just do blockchain. There's some of that too. I mean, basically anyone who is in the semiconductor fab business has the wherewithal to make a custom ASIC. And, well, sorry?
It has a boost in mining too, like an ASIC boost. It's like a 30% like mining boost. That's what you mentioned in China. Like they do have like the mining dominance.
Oops. I think this died a long time ago.
You did.
Okay. So don't even imagine that the JavaScript is going to be a good platform for mining. And Ethereum, which has a different proof mechanism, it's really being driven by GPUs. So also not going to be really useful to try to tackle that with JavaScript. Maybe other altcoins, maybe you can create a JavaScript-based altcoin. It's not much for me. For posting transactions, the real problem, yeah, you can get that. The real problem is the wallets. This wallet.net. If you're in the browser, where's your wallet data? The browser security model is a nightmare for that. You know, are you going to save it on the server? Kind of sucks. There are some things we can do in the browser. I'll talk about that next. And it's not very mature. I mean, I tried 3, I don't know, maybe I got to 4 different JavaScript solutions, which I'm going to talk about next. And when you're talking about a system that could lose millions of dollars, $30 million on a bug, there's significant incentive to use the most mature software out there. So what I actually got the most success with was this wraparound Bitcoin Core. So it's actually using the dominant default software, which exposes a JSON RPC interface. And so the JavaScript is just channeling method calls into that JSON RPC and bring it back to you. And I'll show you some of that. We can't make it work because we're out of time anyway. There are some native implementations that are pure JavaScript. Right? This solution, you have to run this binary that's available on all platforms, but still, can't put it in the browser, for example. These are the ones that stood out to me. There are a couple of others. CoinKey from Cryptcoin, I think is just as good as these guys. Bitcoin.js. It has client and server running the browser node, but it's not full node. It doesn't try to be a full node. It lets you sign in and work with addresses and stuff like that, but it doesn't talk to the network because you can't do that in the browser. I was totally stoked. I thought I was making some great progress with Bitcore, only to find out that it doesn't support Windows. And I was trying to get it so I could run it on this really awesome, super fast machine. And then Bitcoin actually looked pretty good, but I think they were mostly full of shit. they had a link that said, click here, we're running a full node in the browser. Click there, and it's almost a 404.com, so we can't connect. So I think these guys are lying about what their capabilities are. And certainly it wasn't working, so that's why I crossed them out. There are some others around, but the key problem is that in the browser you can't use the native protocols to talk to the chain. So how do you get there? Well, you can have redundant third-party interactions. So we did a hackathon for these DIDs based on Bitcoin, and they had some tools that would use publicly available REST APIs to post transactions and check transactions. So here are some examples. I'm going to post this on our meetup. So if any of you guys want to click on these links and check them out. Using the REST APIs is not considered best practice. So I wouldn't recommend it. But if you're checking multiple to make sure the transaction really posted, it's kind of a workaround. But I think the best option, if you want to do something in the browser that's like a wallet or that has some Bitcoin capability, you want to marry it to some server-side app and have the server-side run the Bitcoin core, so that you're basically writing a web app like any other web app, and a server-side code is doing the actual heavy lifting on the blockchain.
So just for context, this is for just initiating transactions, checking balance, verifying a transaction went through.
That's right. If you want to talk to the chain, like the guys I mentioned who are applying only, they can't do it. So you can go through a REST API. There are services, I think I have at the tail end of the resource section, where you can query the web server with a REST request and get information about a transaction. So you can do that from a JavaScript client to an AJAX query, but you can't reliably post to the chain itself, unfortunately.
Is the chain like a BitTorrent, like a peer-to-peer kind of network that you attach to?
Yes, and I don't understand it well enough to say more than that, but yeah.
Is it over TCP or something else?
Yeah, I think it's over TCP. I'm very unlikely to UDP.
Yeah.
I don't know if anyone knows, but the problem is, you know, the browser wants to isolate you from all that. It doesn't give you full networking set. So you can't even do a straight sockets call, right? You can do the web sockets hack around, but so. Okay, so this is what I did get the most progress with. My local client has not downloaded all the blocks. It took about 2 hours. But basically what you do is you download, this is a C++ app, you can compile it on your own or they have binaries. You want to run it on testnet, so you're not on the real thing working with real money. And if you need to, you can import a wallet. So I had my desktop and I had a computer in the cloud and I was moving the wallet like that around from all these different places. But you could run this with the new wallet kind of rescan. And I'll show some of those commands. So it was pretty easy. Again, I'm in Windows and I Git, so I use Git bash because I like to type ls instead of dir. NVM for Windows, the particular one of my tools named 4.8, so that's what I was using. I'll make a directory, npm within it, just install it. Boom. You're almost there. Because it's a testnet, you can go to a public faucet. And this faucet, you're going to generate, down here, we're going to get a new address. You put an address in that faucet, and they will send you money. Might take 10 minutes, 20 minutes for it to get to you. But you can get online. With the code I have here, and I'll put this in our meetup, you can have JavaScript-driven interactions on the network. So, right, you require the library, you create a new client. You must put in the username and password. And you also must start your Bitcoin core with that username and password. So that's not in the docs, and then the hard way, but you put that in, Then you can start pinging against it. So you can get info is the easiest one. These are all, you can either do a callback or a promise architecture. You can get a balance and get a new address with these commands. They actually just exposed everything that's in the Bitcoin Car API. So it's pretty flexible. I'll leave that link. This is not JavaScript, but that's what I did last week to make sure I understood the underlying technology independent of JavaScript stuff, and these are some other resources. So that's it. That's my introduction of Bitcoin and JavaScript.
Unfortunately, we're past our allotted time. We've got the room until 8:30. And unfortunately, it's a great sponsor. I'll stay a while people keep having events here. We can move it outside downstairs. We want to head out there if anyone wants to stick around. If not, next month we've got design up design right back here. You want to talk about JavaScript? Let us know. Sorry for the quick cut off here, but we got a lot of hosts. Thanks, guys. Thanks, everyone, for coming.
Thank you. And thank you.